The issue concerns clearance around a machine room door and a possible misinterpretation of the National Electrical Code, specifically Section 110.26a. It appears the rejection was based on the door infringing upon the required 3.5-foot clearance, but the inspector cited a non-existent code section, 620.72. There is no section 620.72 in the NEC. The relevant code section is likely 110.263. This section addresses situations where the workspace mandated by 110.26 results in a door swinging into the working space of other equipment, switches, or panel boards. In such cases, the NEC requires suitable means to be provided to protect that equipment, switches, or panel boards from damage. Let's break down the key elements of this code section to understand its practical application. Firstly, the code mandates a working space around electrical equipment. This working space ensures that electricians and other qualified personnel have sufficient room to safely inspect, maintain, and repair the equipment. The dimensions of this working space are determined by the voltage of the equipment and the specific conditions of the installation, as outlined in 110.26a. Secondly, the code recognizes that in some situations a door may swing into this required working space. This is common in machine rooms or other confined spaces where equipment is located near doorways. Thirdly, the critical aspect of 110.26 is the requirement for suitable means to protect equipment from damage if a door swings into its working space. The NEC does not explicitly define what constitutes suitable means, but it implies that a physical barrier or other protective measure must be in place. There are several possible interpretations and applications of this code section. The inspector's rejection suggests they believe the machine room door swings into the working space of other equipment. They also believe that no suitable means are in place to protect the equipment from potential damage caused by the door. Consider the inspector's perspective. They are responsible for ensuring that the electrical installation meets the minimum safety standards outlined in the NEC. They must consider the potential hazards associated with the door swinging into the working space of electrical equipment. What constitutes suitable means of protection depends on the specific circumstances of the installation. Here are some examples of suitable means, although the suitability depends on the specific installation. One example is installing a door stop. A door stop can prevent the door from swinging fully open and potentially hitting the electrical equipment. The door stop must be positioned to ensure that the door does not encroach on the required working space or pose a hazard to the equipment. Another example is installing a barrier or guard. A physical barrier, such as a railing or bollard, can be placed around the equipment to protect it from damage caused by the door. The barrier must be sturdy enough to withstand the impact of the door and must not obstruct access to the equipment for maintenance or repair. A third example is modifying the door swing. Reversing the door swing so that it opens outward or away from the equipment can eliminate the hazard. This may involve relocating the door hinges and potentially the door frame. A fourth example is relocating the equipment. If possible, relocating the electrical equipment to a different location within the machine room can eliminate the conflict with the door swing. This may involve rerouting electrical conduits and cables. A fifth example is installing a door closer with adjustable speed. A door closer can control the speed at which the door swings open and closed, reducing the risk of impact damage. The door closer must be adjusted to ensure that the door closes smoothly and does not swing too quickly. When evaluating suitable means, several factors should be considered. Firstly, consider the voltage of the equipment. Higher voltage equipment requires a larger working space and may necessitate more robust protective measures. Secondly, consider the type of equipment. Some equipment is more sensitive to damage than others. For example, delicate electronic equipment may require more protection than a simple disconnect switch. Thirdly, consider the frequency of door usage. If the door is frequently used, the risk of impact damage is higher and more robust protective measures may be necessary. Fourthly, consider the size and weight of the door. Larger, heavier doors pose a greater risk of damage and may require stronger protective measures. To address the inspector's concerns, a thorough evaluation of the machine room layout is crucial. This evaluation should include the following steps. Firstly, verify the required working space. Measure the distance from the front of the electrical equipment to any obstructions, including the door when it is fully open. Ensure that the working space meets the requirements of 110.26 ohm based on the voltage of the equipment. Secondly, assess the door swing. Observe the path of the door as it swings open and closed. Determine whether the door swings into the required working space of any electrical equipment. Thirdly, identify potential hazards. Identify any equipment that is at risk of being damaged by the door swing. Consider the type of equipment, its sensitivity to damage, and the frequency of door usage. Fourthly, evaluate existing protection measures. Determine whether any existing measures are in place to protect the equipment from damage. These measures may include door stops, barriers, or other physical safeguards. Fifthly, propose suitable solutions. If the evaluation reveals that the door swing poses a hazard to the equipment, propose suitable solutions to mitigate the risk. These solutions may include installing a door stop, installing a barrier, modifying the door swing, or relocating the equipment. Sixthly, document the findings. Document the findings of the evaluation, including measurements, observations, and proposed solutions. This documentation can be used to demonstrate compliance with the NEC and to justify the proposed solutions to the inspector. The key to resolving this issue is to engage in a constructive dialogue with the inspector. Present the findings of the evaluation, explain the proposed solutions, and demonstrate that the solutions meet the intent of the NEC. The inspector may have valid concerns that need to be addressed. By working collaboratively, it is possible to find a solution that satisfies the code requirements and ensures the safety of the electrical installation. If you disagree with the inspector's interpretation of the code, there are established procedures for appealing the decision. Consult with a qualified electrical engineer or a code expert to determine the best course of action. Understanding the relevant code sections and working collaboratively with the inspector is essential for resolving this issue. By taking a proactive approach and demonstrating a commitment to electrical safety, it is possible to achieve a positive outcome. Remember, the NEC is a complex document and interpretations can vary. It is important to stay informed about the latest code requirements and to seek clarification when needed. Electrical safety is paramount. By adhering to the NEC and implementing appropriate safety measures, we can protect people and property from electrical hazards. In summary, address the machine room door clearance issue by focusing on National Electrical Code Section 110.26(3). Ensure adequate protection for equipment potentially impacted by the door's swing, and engage in open communication with the inspector to reach a mutually agreeable solution that prioritizes safety and code compliance. If disagreements persist, explore available appeal processes to ensure a fair and accurate interpretation of the code.